Solving logarithmic equations. So here's our first type, and our first type is going to look like a log equals a log. So for instance, if we had the log base b of x equals the log base b of y, you'll notice that the log and their bases match, which means that what you're taking the log of must match. Therefore, all we have to do is solve the equation that x equals y. So since the logs match, what you're taking the log of must also match. So let's see how that works. So in this one, we have the log base 6 of 5 equals log base 6 of 23 minus 4x. So the log base 6's match. This only works if they match, which means what you're taking the log of, which is a 5 on one side and a 23 minus 4x on the other side, must also match. So you can say that they equal each other. So then all I got to do from here is solve them. So if I were to solve them, I would get negative 18 equals negative 4x. And if I divide negative 18 by negative 4, I would get a fraction of a negative divided by negative is a positive. I can divide both of those by 2, and I get 9 halves. Let's try another one. Problem number 2. First, you'll notice that on the right-hand side, it is 2 separate logs. So we need to actually use the property of logs first. So if you have a 3 out front, it really is an exponent. So this is really log base 5 of 2 to the third power is 8 plus log base 5 of 7. And it still equals log base 5 of x. Now I can put those together. If I'm adding with the same log base, then to put them together, I just multiply. So 8 times 7 is 56, and so that still equals the log base 5 of x. Now you'll notice that they both say the log base 5 equals log base 5. This is why it's one of those log equals log problems. And we have an x, and it equals 56, and we are done with that one. So using the property of logs is also going to be something you need to do today. Okay, on this problem, we also again on the left-hand side have 2 logs going on, so we need to use our property of logs. If you have a 4 out front, it becomes the exponent. So this is going to be log base 2 of x to the 4th minus log base 2 of 5 equals log base 2 of 125. So on these ones, they are both log base 2. So if I'm subtracting, it means a division problem when I put them together using the law of the property of logs. So this becomes x to the 4th over 5 because I'm dividing since it's a subtraction problem. And then I have log base 2 of 125. So now I have a problem that it is log equals log, and their bases match, which means I can basically ignore the logs, and I have x to the 4th over 5 equals 125. So if I solve this for our x, I'm going to multiply both sides by 5, and I'm going to have x to the 4th equals, and 125 times 5 is 625. And then if I want to undo the 4, the exponent of 4, I take the 4th root. So if I take the 4th root of 625, this actually is an answer because 5 multiplied by itself 4 times is 625, so x equals 5.